Take a second and picture writing the number 23. For an adult, the brain executes this command instantly. But if you ask a young child just learning math to do the same thing, they frequently write down something else entirely, 203. This happens because our base 10 number system isn't a natural human instinct. It is a highly counterintuitive, invented technology. To accurately read and write these numbers, a learner has to process 3 distinct sets of logical rules, all of which are completely invisible to the naked eye. By examining 3 common mistakes kids make when learning math, we can reverse engineer the exact structural logic that makes modern mathematics possible. The first physical limitation of our numbering system is that we only have 9 distinct symbols. Without a way to recycle them, we would have to invent an infinite number of unique characters to count higher amounts. A child first learns to count by looking at isolated single objects. They count 1, 2, 3, up to 9, and then they hit a cognitive ceiling because they are only processing individual items. The required logical patch for this is called unitizing. This is a cognitive leap where a specific quantity of items is suddenly treated as one entirely new object. This manual image shows educators training the brain to see this logic. You start with scattered individual sticks, grouping 10 together. The mathematical transition happens the moment a rubber band goes around 10 straws, making them a single bundle. This logic of the threshold is the foundational patch. It upgrades the human brain from merely counting items to counting groups. Once a learner grasps groups, they run into a second diagnostic glitch, writing a 31 when they actually mean 13. To an untrained brain, the symbol 1 and the symbol 3 possess fixed intrinsic values. A 1 is a 1 and a 3 is a 3, regardless of where you place them on the page. Fixing this requires a second logical patch, positionality. This is the rule that geography dictates value. On a grid, a dot in the ones column is 1. Sliding left into the tens column multiplies it into 10. Applying this to 13 versus 31 shows that swapping the digits changes the scale of the number entirely. Positionality is an ingenious spatial patch that allows us to map infinite quantities using only our 9 original symbols. We can now use these rules of units and space to diagnose our original error, writing 23 as 203. This glitch is an auditory trap. A child hears the distinct words 20 and 3 and logically writes them down sequentially, exactly as they sound. To overcome this, the brain must apply the final logical patch, additive assembly. There is a hidden mathematical operation embedded inside every single multi-digit number. This image highlights a diagnostic tool called arrow cards, exposing this hidden operation. The fully assembled number 4073 sets at the top. Sliding the cards apart reveals the invisible addition equation normally hidden when stacked. 0 serves as a structural placeholder, pinning every other digit to its assigned column to maintain the integrity of the sum. Reading a number isn't simply identifying characters, it is instantly computing a highly compressed addition problem. Bringing these teaching tools together, the bundles, the positional grid, the layered cards, gives us a complete picture of the base 10 system. These objects act as the mechanical gears of our numbering system, turning the intangible rules of mathematics into something we can physically touch and manipulate. We group by 10, we multiply by location, and compress through addition. Successfully navigating the base 10 system requires the simultaneous management of grouping, scaling, and additive compression. It is the foundational logic that allows us to collapse massive amounts of abstract data into a readable, scalable code.